Hello and welcome back to Functional Analysis, and many thanks to all the nice people that support me on Steady or PayPal. Today in part 14 I want to show you one example how to calculate the operator norm. In this example our norm space X should be given by the continuous functions. The domain of the functions should be the unit interval and the codomain the complex or real numbers. And the common norm for this space is the supremum norm. And the second space Y should be just the complex or real numbers together with the absolute value. Hence today we will consider a map T that sends a continuous function to just a number. In order to define this operator, I want to fix a continuous function g. To make our life a little bit easier, the function g shouldn't have any zeros. Now for each such g, we define an operator t, and therefore I put an index g to it. Now the operator sends a function f to a number by the following definition. It's the integral of the function g multiplied with the function f. Now because we are only dealing with continuous functions, you can read this as a Riemann integral or a Lebesgue integral. It does not matter. The question for us is this a bounded operator? Or the similar question, what is the operator norm? For this, please recall that the operator norm of Tg is given by a supremum. More concretely, we have the norm of the output divided by the norm of the input. And then we go over all functions of x with the exception of the zero vector. So what we can always do is apply the scaling as we did it last time. We can do that such that we only divide by 1, so we consider only functions with supremum norm 1. Of course you don't have to do that, but it makes our life easier because we don't have to write down a fraction here. In the next step we just fill in what we know from the image. We have here the absolute value of this integral. This integral is of course what we need to calculate, but maybe a better first step would be to find an estimate. Now I want to use the knowledge that pulling the absolute value into the integral only makes it bigger or it stays the same. And then we just use the multiplicativity of the absolute value, which means we can pull out the multiplication sign. Then in the next step we see that we have here the absolute value of f at some point t. However, this can't be bigger than the largest value, which is given by the supremum norm. Which means that we have here a constant and we already fixed that to 1. In summary, the supremum can't change anything anymore, so we know the operator norm can't be bigger than the integral of g. And we already know this is a finite number because we have a positive continuous function inside the integral. So indeed, this is a bounded operator. The last question that remains is, what exactly is the operator norm of Tg? Do we have in fact an equality sign here, or is the operator norm really less than this integral? In order to answer this question, it's always good to look at some examples, because then you get a lower bound for the whole supremum. And if you do that, you might find that you also can use the function g as an input. However, then we can't use this line here, because here we need that the supremum norm of the function we put in is exactly 1. But of course you know we could change the function g in such a way just by dividing by the absolute value of g. So let's call this function h, and I also want to add a complex conjugation here, which will be helpful later. Now it's easy to see the supremum norm of h is exactly 1. Now putting this function into Tg and looking at the absolute value, then we know this has to be less or equal than the operator norm itself. On the other hand, we know this is the absolute value of the integral where we have the function g times h. And now you see why we added the complex conjugation before, because now we have the absolute value squared in the numerator. We can omit the absolute value outside because everything is positive here, and we also can just cancel out one absolute value of gt. And then what remains is exactly the same integral as before. And now we can put both inequalities together and find out that the operator norm of the operator Tg is exactly this integral. Okay, so this was one quick example of calculating the operator norm of an operator between two normed spaces. In the next video I want to start talking about operators between Hilbert spaces. So thanks for listening, thanks for supporting me, and see you next time. Bye!